Let us start off by identifying an arithmetic operation. An operation is made up of what is called an operator and an operand. An operand is the actual thing that the operation is going to be done on. The noun, the thing. Usually these are numbers or other values. In arithmetic, in algebra, we can see them as variables or constants. In arithmetic, we usually use literals. These are the numeric values written using numerals. Those are the operands, the nouns, the things. And then the operators are the actions. So what are you going to do to that operand? Fetch me some water. Fetch some water. See, that's the operation is fetch some water. The operands are the person who is being instructed. You are the operand. You're the person who's going to do it. And the water, the thing that you're going. Those are the two things which are involved. And then the operation, the exercise, the activity is the fetching. So the basic arithmetic operators are plus, minus, times, and divide. Those of you who want to study maths even further, you'd actually realize that there's only one operator there, that's plus. Everything else is based on that. Anyway, that's neither here nor there. We're going to look at the four basic operators: plus, minus, times, and divide. We also have three others, as you see on this table there, that we would like to have an appreciation of. What I'm going to show you here is the name of the symbol, rather the name of the operator, the symbol, the handwritten symbol there, and how you normally write it on the computer symbol, the computer representation. Because sometimes it's very difficult it's a longer process to try and get the hand symbols on the computer. They are there. For instance, the multiplication, the divide sign. If you try to look for it on the computer, there's a bit of a process that you have to go through. So to avoid that, we just use that /. And then for multiplication, yes, to avoid that's not an X, by the way, as you can see. We use the asterisk there. Right. And we will also see that for the exponent, x to the power y, would sometimes use that cap symbol there to say x, cap, and then y. That means x to the power of y. For the root, you'll find that this is how it's often displayed. The symbol is there, and in the computer you would write it similarly. And then finally we have the modulo division. Modulo division uses what looks like a percentage sign. The thing about it is you'll see it will be in the middle. It is represented as an operand, as an operator inside an operation. So you'll be able to see that this is not percent. It's actually an operation. Okay, so what's the function or description of addition? It gives the sum. For example, there 12 plus 3 is 15. Subtraction gives the difference. For example, 12 minus 3 is 9. Multiplication gives the product. For example, 12 times 3, notice how it's written using the computer symbols, because this is how you're going to meet it all of the time. It's 36. The division there also, we've used the computer symbol there, which is a /. 12 divided by 3 is 4. So having said that, we can now move on to this next one there, the exponent. There is a little section that will be dealing with exponents only, but what's happening here is multiplication. It's important to remember is a shorthand for addition. When you say 12 times 3, you're basically saying 12 plus 12 plus 12. You're adding 12 to itself 3 times. That's what times 3 means. It means you're just adding the same number to itself. And then you say, how many times are you doing that? 3 times, so it's times 3. So exponents work in a very similar way, but this time it's not about addition, it's about multiplication. An exponent simply means that you're multiplying a number by itself, the number of times that is expressed on the exponent. For instance, 12 to the power 3 simply means you multiply 12 times 12 times 12 times 12 times 12 times 12. Just keep multiplying 12 by itself, but only 3 times in this case. So it's just 12 times 12 times 12. It should give you that. The root, this is a very difficult one to explain, but it's something that's there because, like I always say, it's even finding roots is quite difficult. A lot of the time it involves some guesswork. There are some formulas for finding roots, but they are very complex and very long. The process is quite long in order to be able to actually find the square root of a number. And other roots, the more the root becomes bigger, the more complicated it becomes. But anyway, here's an example of what a root does. It finds a number that is multiplied by itself in order to get that number there. Right, so in this case here, we find the third root of 1728 to be 12. This basically means that if you multiply 12 by 12 by 12 3 times, you'd get that number. So basically what's happening with the root is it's reversing the exponent. And then finally we have modulo division there, where we are saying that for modulo division, the answer of a modulo is basically the remainder after dividing. The remainder after dividing. In the example given there, we see that the modulo 12 modulo 3 is equal to 0. Why is it 0? Because 12 divided by 3 is 4, remainder 0. So we just take that remainder there. Or 10 modulo 3. What happens there is you divide 10 by 3. The answer is 3, remainder 1. So the answer there for 10 modulo 3 is just 1. You don't say 3 remainder 1. You just take the remainder alone. Like this video and subscribe to this channel for more such content.